In this video, we're going to calculate the correlation. And the formula for the correlation is as follows. So what it says here is that we divide the covariance by the standard deviation of x and the standard deviation of y. So what we can also say is that r is equal to the covariance divided by these two standard deviations. All right, well, let's focus on the covariance first. The covariance of x and y is the sum of x minus mean x multiplied by y minus mean y divided by n minus 1. We're going to calculate an example with a few data points. We're going to give x and y both 5 data points, 1, 2, 3, 4, 5, and 6, 11, 7, 8, and 13. And we're now going to calculate x minus mean x and y minus mean y. So what we need is the mean of x and the mean of y. The mean of x is 1 plus 3 plus 4 plus 5 divided by 5, which equals 3. And the mean of y is 6 plus 11 plus 7 plus 8 plus 13 divided by 5, which is 9. Next, we're going to calculate x minus mean x. So we have the mean of x, which equals 3. So we get 1 minus 3 equals minus 2, and so on. And we will now do the same for y minus mean y. So in this case, 6 minus 9 is minus 3, and 11 minus 9, 7 minus 9, 8 minus 9, and 13 minus 9. So next, we have to multiply these two with each other. So let's zoom in. Multiplying x minus mean x by y minus mean y results in 6, minus 2, 0, minus 1, and 8. I'm just going to drag everything out of the way. Oh. So this can also be represented in a chart in which we plot x against y with x on the x-axis and y on the y-axis. So we're going to draw in the data points in the chart, 1x, 6y, etc. And then we are also going to now draw mean x and mean y in the chart, and we do this to make it visually clear what we do with these multiplications and why. The mean of x equals 3, and then the mean of y equals 9. And so x minus mean x is the difference score between the data points x and the mean of x, and we can display this with these red lines. And y minus mean y is the distance between all data points of y and the mean of y. And we can now do all multiplications with the different scores x minus mean x and y minus mean y. And if we multiply these, they are positive in the lower left quadrant and the upper right quadrant, because a positive multiplied by a positive is a positive, a negative multiplied by a negative is a positive, and a negative multiplied by a positive is negative. So the more data points there are in the lower left quadrant and the upper right quadrant, the higher their covariance gets. So next we need the sum to actually calculate the covariance. So what we're going to do is we're going to add all these numbers together, which equals 11. And that's the upper part, the numerator of the covariance formula. The lower part of the covariance formula is n minus 1. We had 5 observations, so we divide 11 by 4.